Today we thought we'd show a quick demonstration of the palm scanner, one of the scanner kits that we have available, with an array probe and a specialized wedge uh, aimed at heavy-duty boiler tube inspection or piping inspection in general. But here I've got a pipe that's about 1.5 inches, 2 inches in diameter, has about a 5 millimeter wall. This palm scanner arrangement is a clever mechanical setup. It snaps on to around the pipe, has an encoder wheel built right in. You just kind of fold the wings open, snap it right on the pipe. It has a couplant feed system as part of it, or at least the tubing for couplant feed is provided as part of this assembly. The pump to deliver water to it and so on isn't included. But today I'm just going to create a little bit of a gap and run some water and glycerin couplant in there to give us something to work with. Okay. We have an app to go with this called Boiler Tube Weld app. And we're going to cheat a little bit here because my sample that I have actually doesn't have a weld. This would be aimed at inspecting, say, a girth weld, 2 pieces of pipe butted up and welded. In my case, I've got a nice clean piece of pipe here, but there are 5 different holes drilled at different angles and different depths. They're all about, they appear to be about 1/8 of an inch diameter holes. Again, different depths. The first one's very shallow. The drill bit just kind of touched the surface. Next one's a little deeper yet, all the way through at 2 different angles. So we'll see what those look like as we scan. So, welcome page, some information about the selection of palm scanners. We have several different size scanners for different diameters of pipe. You know, the wings open up more. The probe is fairly consistent. The wedges are going to be unique to a particular diameter of pipe, right? Because they have to be cut for the curvature of the pipe. Okay. More information on the specific probe, wedge, and scanner arrangement used here. Okay. And we have an initial setup, so we can look at just a sector and a scan from the pipe. So there's a clean area of the pipe. And there's the first shallow hole. That's the one where the drill bit just kind of touched the surface. A little deeper hole. Deeper yet. All the way through at one angle. And this is back to a hole in the surface again. Or just a sort of a touch of a drill bit. Okay. So basic setup. Okay, so here we're going to peek up on one of our holes. I'm just going to pick this one near the surface. I'm going to move gate A up to cover that. Select beam. Auto 80. So what I've done is peeked up on the first shallow hole, selected that hole, that indication, used the beam selector to select that indication, made sure my gate was over the indication, hit calibrate, and it did a sensitivity calibration, auto 80. Okay. So now we're going to set up our scanner, calibrate our scanner. So it's already been set up with 314 millimeters, which would be the circumference of the pipe. So I'm going to line up on the first hole as kind of an indication, and I'm going to say start calibration. I'm going to rotate the pipe 1 full rotation. There's one rotation. Then I'm going to go backwards to check for backlash. I'm going to go back to my indication. There we go. And the encoder's been calibrated. So at this point, the encoder, one good revolution should be 314 millimeters. Go to our scan panel, we'll clear, and as I rotate, okay. So we can clear that just a little, and we'll record. Oops, missed a little back up. Okay. So we'll stop our recording. I'm going to move my gates down just a little bit here, so that I'm covering more of one good thickness of the part. And we see our 5 indications. So first one, I bring the crosshair over. There's the indication from the hole that's just barely touching on the surface. Next deeper hole, deeper yet, one all the way through at an angle, and there's the 5th indication. Again, a little bit back towards the surface, but being picked up by the steeper beams. So that's the boiler tube application. Again, combining this clever scanner that snaps around the tube. You know, here I was holding the scanner and turning the tube. Of course, in the field, in an actual boiler, you would snap the scanner on and then move the scanner around the pipe. But it's a nice low profile device. So you could get this between adjacent tubes that were no more than, I would say, 3/4 of an inch apart. So if there's 3/4 of an inch of separation between adjacent tubes, you can snap that scanner on, rotate it around a tube. It follows a nice circumferential path. You can set up the setback distance from the center line of the weld to the face of the probe very easily. Snap it on, slide it around, and it's going to follow a nice path as you take it around the tube. Okay, so that's the boiler tube equipment and application that we have available. Again, those scanners are available in 3 different sizes for a range of tubing sizes. We'll clear this and go back to scanner selection panel. There you can see the different sizes of scanners and probes, wedges that are available. Okay, any questions on that much?
Yeah, hey, Dan.
Yeah.
Yeah, let me just make a comment there. Guys, this is the series of scanners that, we, gained access to with the awesome acquisition by GE about a year and a half ago. And that's what the now the combination of being able to use them with the Mentor UT is a big deal. We previously sent out information on these sensors, and following this call, I will resend some more updated information on it.
Yeah. Hey, Dave, if you're using your headset, you might want to.
Probe recommendation, wedges, and prices, part numbers. Yeah, correct. Yeah, I'll get that out, Al. Good point.
Yeah, Dave, if you're using your headset, you might want to switch off. You're breaking up from time to time.
Okay, thanks.
No, it's still breaking up.
but Al, yeah, we will get that information out as requested.
Okay. Any other questions on the?
Yeah. This is Stephen. For the offline data, what is the time frame of being able to look at that encoded scan and go back and change angles and do measurements offline? Do we have a time frame?
Well, I'm going to show here, Stephen, in the next couple of minutes, I'll show recalling a data file and doing some analysis on the instrument. I believe Mentor PC, the PC version of the software, I believe is to be released with the 2.1 release. Once again, we had a version out there for 1.2 the 2.0 version of it didn't make it through the release process, but I believe the team's intention is to have Mentor PC back again for 2.1. Yep. Okay, so I'm going to drop out of the Boiler Tube app here for a second and go back to our familiar app that we looked at the last time, the Phaser XS app. And here I'm going to get back to some data that we collected. I believe we collected this the last time in the last webinar. So I'm just going to go to my scan panel here. And I don't have the probe or anything connected that we use to collect this data. I still got the boiler stuff connected, but that doesn't matter. We're just going to reload the data. So this is a data set file that we saved the last time. Okay. And now we're just going to look at some of the analysis tools that are available. So if I come in here, actually what I'm going to do is okay. So the first thing I'm going to do is I've recalled the data. So I'm going to use my finger gestures to draw a box on the C-scan around an item that looks interesting. Okay. Can pop that open. So double tap on the C-scan on any of these data views actually will expand them to full screen, so I have a little better resolution of what I'm looking at. But again, just like we had back in the corrosion apps, if I draw a box on the overview C-scan, that becomes the contents of the active C-scan. And I can pop that up to full screen. Now if I come in here and draw a box, there are some new features that go with this measurement box. One is the length of the box can be used as a measuring device. So because I recorded this in timed mode, it's telling me that box is 1 second from the left side to the right side. If this was an encoded scan, it would be showing in inches or millimeters. The crosshairs can be moved around, and we have the position, X and Y position shown in the upper right corner, as well as the amplitude under the crosshair. Okay, so this begins to give me some sizing tools. I can get an idea of just visually, based on the colors of the A-scan, I can do an approximate 3 dB down from the hottest point kind of sizing of that box. Okay, right now the Y position is not also being given, or the Y size isn't necessarily being given. Hopefully in 2.1 we pick that up. But just using the crosshair as a ruler, we can say there is Y of 3.35, 2.48, so about a millimeter from top to bottom. Same kind of thing can be done with this. We also have some new measurement tools on the sector scan. We talked a little bit about the weld overlay the last time. Other things that we can turn on here are the origin line display, which shows the dashed line down the middle. That would be the center line of the weld. The position with respect to the probe is based on the offset, the index offset, and the wedge front parameters of the probe. So if I look at wedge front, it was 24 millimeters from the entry point of the sound to the face of the probe. And if I look on the display, we add to that under the materials menu the index offset. So that added together said when I did the scan, it was 30 millimeters from the center line of my weld back to the face of the probe. And then it was another 24 millimeters from the face of the probe back to the beam index point. So that's why zero's out here in the middle, and we're back about 50 millimeters more or less where the sound is entering the picture. Okay. So now when we are analyzing, if we go to here, so I have 1 or 2 crosshairs available to make some additional measurements here in the sector. So I've got one set of crosshairs here. Okay, and that's crosshairs 1. Crosshair set 2 is yellow. Okay. And we have a number of measurements up along the top of the screen here. We have depth and projection for 1 and for 2. Okay, you can see those numbers changing as I move crosshair 1 around. Also, depth and projection of 2. Okay. And then we also have depth difference from 1 to 2 and projected difference from 1 to 2. So I can use these crosshairs to begin to do some sizing estimates on the defects. Okay. So the display does get a little bit busy. You may choose to have the weld overlay turned off to clean things up a little bit. Might make it a little clearer. Okay. Start to simplify things a little bit, turn the origin line off as well. Okay, so now we're down to just beam selector and the 2 crosshairs. Okay. So each of those tools again comes with a selection of readouts. We pop open create here for a second. You can see I have only, if I select the sector scan, here's where I turn on which readouts I want to see across the top of the screen. And the definitions of these are covered in the manual, so I'm not going to get into a lot of detail here on that. But it's you have a selection of beam path, projected distance, depth distance measurements that you can do on the sector. And again, you have a choice of 1 or 2 crosshairs. So just one crosshair on is always going to be your crosshair 1. So depth, projection, all that is based on the single crosshair. If I go back, turn weld overlay on here again for a second, you can see how the depth will follow the actual thickness of the part. So there I'm putting my crosshair right on the bottom of the V. So it's showing my depth is 18 millimeters and my part thickness is about 18 millimeters, 19 millimeters. So you can see how that lines up. Now, if I grab my crosshair, come back to the surface, top surface of the weld, you see how my depth number is down to almost 0. Then as I get into the third leg, we start going deeper again, deeper, 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 right down to 19. Then we'll start back towards the surface again. Okay. So those are some of the basic analysis tools. There are lots and lots of different measurements that you can take using these. Some of those need to be configured in terms of the measurements you're interested in. Those are configured in Create, as we see here. At the time you choose which of the measurements will be displayed along the top. Same thing for the C-scan. Some of the measurements are appropriate for corrosion or thickness measurements. Min, max, lots of these are thickness measurement things that don't necessarily make a lot of sense in an angle beam weld inspection. So depending on the type of application you're setting up, the kind of inspection you're going to do would drive the choices of which parameters you make available for measurement. Okay.